सब्सक्राइब कीजिए जेईई फिजिक्स को एंड बेल आइकन दबाइए लेटेस्ट वीडियो सबसे पहले देखने के लिए।
Hello NEET aspirant. Today I have taken chapter error in measurement and we have designed this chapter into two parts. One part is for the beginners and the second part will be for advanced level or for NEET exam, and this class is for just for beginners. So if you are a NEET aspirant or a class 11 student, then it will be beneficial to you. And for NEET aspirant, I suggest you that first complete the course of basics, because if you know the basic, then you can be answered of any advanced level question, and if you don't know the basics, then it will be difficult to solve the problem which are very much tricky. So this is part 1 of the video in which I will discuss the basics, and in the part 2 I will discuss the advanced level of the topic error in measurement. So first I have to discuss what is an error in measurement. In physics, we are going to discuss many measurement. In your laboratory, you measure different physical quantities such as mass of a body, length of an object, or density of an object. Then you have to use different type of instrument. So in different type of instrument, you must have some error in measurement. What is an error? Suppose you are measuring a physical quantity, the mass of an object, then you can get by measurement a value which is not correct, that is, which has some mistake or which has some deviation from the actual value. If actual value of a physical quantity is A and you get a quantity different from A, so let the actual value is A and you get a value A1, then the error is A minus A1. So what is an error? Error is the deviation in measured value from the actual value. Now, where from the errors are come? The errors are come from different sources, such as if you may measure a value, measure a physical quantity with lack of care. That is, carelessness is one of the root of error in measurement. Secondly, the instrument you are using may be wrongly calibrated, or maybe it is not too accurate, then it will give rise an error in the measurement. And randomly few error may becomes. So we categorize the error into two parts. So if error can be divided into two parts. One is systemic error and other is random error. Systemic error. What is systemic error? Systemic error may be classified into different parts, such as first, instrumental error. What is instrumental error? Instrumental error is the limitation of the instrument. Instrument may be wrongly calibrated, or it's, if you are using a vernier caliper, then the zero of the scale and zero of the vernier scale may not be coincide when there is no object present in the vernier calipers. So this can insert an error is called zero error in of the instrument. The second is imperfection in experimental technique. Imperfection in experimental technique. What is experimental technique? So you have to measure, suppose, length of a instrument. Suppose you are going to measure the length of this. So you put a scale here, suppose in this way. So this is your scale, which is this is 0 and some measurement. So you have to measure this line, the number of this line. Now if you look through this side, you may not get the correct value. If you look from this side, also there will be some error. You have to look in perpendicular direction, and the error come from, if you are not look from this perpendicular direction, this error is called parallax. So parallax may come from improper experimental technique. So if you have problem in technique, then error may come from. Backlash error is one of the very important error. Backlash error. What is a backlash error? Backlash error is, suppose you are working with an spectrometer. Now in spectrometer, you are going to measure the position of blue line of spectroscope. Then you are rotating the spectrometer in clockwise direction, and going through this rotation, suppose you crossed the desired line. Then what will you done? You reverse the direction. Suppose you are first going towards clockwise direction, you cross it, so you now going to be anti-clockwise direction to get in the position of the line. But in this process, 1 or 2 least count may get. So there come an error due to backward movement of the screw. This error is called backlash error. Second is personal error. Personal error come from careless measurement. If you are careless in measurement, not measuring with concentration, then an error may come from this. It's called personal error. These are all the systemic error. Now, what is random error? Random errors are those root of which we cannot determine. So, in the error, we can find out different roots of error, such as I told you that instrumental error, imperfection in experimental technique, and backlash error, personal error, etc. But there are also few errors that are come in the measurement, but we have no control in these types of error. We cannot avoid them. These are called random error. They are come randomly in the measurement, so we cannot correct them. And the one important thing is least count error. What is least count error? Every instrument has a least count. What is least count? Now in our watch, we know that the minimum time duration we can measure, it is 1 second. So 1 second is the least count of our everyday used watch. If you go to a shop and see their weight box, there will be few weights, and the least value of the weight is 50 gram. Then the least count of the common balance is 50 gram. Take a meter scale. The minimum distance between two lines in the meter scale, that is the distance between these two lines, is of 1 millimeter, and so the least count of the meter scale is 1 millimeter. In the same way, the least count of a slide calipers may be 0.01 centimeter, of a screw gauge is 0.001 centimeter is least count. Now, what can I do to avoid the error in the measurement? To avoid the error, we can use such instrument which have no zero error and which are well calibrated, and we can put our attention in measurement so that personal error does not come here. And we cannot avoid random error, so random error will come into account, so we cannot avoid them. Now come to mathematics of error calculation, and in mathematics of error calculation it will help you to solve the problem which are asked in NEET JEE, West Bengal JEE, etc. These exams. So this was the basics of the error. Now I will discuss some about error. So we have a physical quantity which have to be measured. So to reduce the error in measurement, we take several measurement of a physical quantity. Let A is a physical quantity I have to measure. So I will take several measurement in the finding the value of the physical quantity. And let I get 10 measurement of A, that is A1, A2, A3, A4 and A5. Let us take 5 measurement. So we measure 5 times the A. Suppose you are measuring the length of a rod, so you measured the length of the rod 5 times. So we get A1, A2, A3, A4, A5 are the measurement. 1 or 2 measurement may be identical. Then what is the value of this physical quantity? We have to take the mean. So the value of the physical quantity A is equal to A1 plus A2 plus A3 plus A4 plus A5 divided by 5. We have taken 5 measurements, so we will add them and divide it by 5 to get the actual value. So we have got the value of the physical quantity. Now this A, what I find, may be different from A1, A2, A3, A4, A5. Suppose you are measuring the rod, length of a rod, and you get 5 measurement, 5.02, 5.01, 4.96, 4.98 and 5.00. You get these 5 measurement. So the average value of the measurement x equal to 5.02 plus 5.01 plus 4.96 plus 4.98 plus 5.00 by 5. It is equal. It is equal to nearly 4.97. So we get A is 4.97, while A1, A2, A3, A4, A5 was 5.02, 5.01, 4.96, 4.98 and 5.00 respectively. Now we see that every measured value is deviated from the average value. 5.02 is deviated from here. sorry, it is 4.99. So 5.02 is deviated by 0.03. 5.01 is deviated by 0.02. So it said that all value was deviated from this result. Then we have to find the error in measurement. So A1 is the first measurement, and the error in measuring A1 is delta A1 is equal to A1 minus A. This one. Error in the measurement of A2 is A2 minus A. Error in the measurement of A3 is delta A3 is equal to A3 minus A. Error in the measurement of A4 is equal to A4 minus A. And error in the measurement of A5 is A5 minus A. So these are the error in the measurement. These are called absolute error in the measurement. Now these are 5 error, and to get the absolute error in the measurement of A, we get error in measurement is equal to delta A1 plus delta A2 plus delta A3 plus delta A4 plus delta A5. We have 5 error, so divide by 5. So this is the mean error in the measurement. So we get mean value is A and error is delta A. Now error can be positive or can be negative. We always take error as positive. So the actual value is equal to measured value plus minus error. So this is the measurement of physical quantity, and when you find a physical quantity from experiment, you have to write in this fashion, that the value of the physical quantity here A plus minus delta A. So what it means? It means that the actual value is greater than or equal to A minus delta A and less than equal to A plus delta A. For example, suppose you are measuring the length or the time period of a second pendulum. So you get the time period is 1.98 second, and you get delta t is 0.02 second. What it mean? It means that you have taken a pendulum whose time period t lies between 1.98 plus 0.02 and 1.98 minus 0.02. So the measurement is 1.96 to 2.00. So you are saying from your experiment that I have get the time period of a simple pendulum in the range 1.96 to 2.00. It is the same as telling that time period of the pendulum is 1.98 plus minus 0.02 second. Now this measurement is the absolute error, but absolute error does not give the actual information that the how the quantity is deviated and what is the amount of error, because in measurement it is depends on what is the actual value of the measurement. How? Suppose you are measuring by experiment that the mass of a ball. Now let the actual mass of the ball is 10 kg, a heavy ball, and the actual mass is 2 kg, 10 kg. And in another experiment, the actual mass of the ball is 10 gram. Now let the absolute error in the both cases. Here the absolute error is 0.5 gram. Sorry, it is 5 gram. And here also the actual value is say 5 gram. Then in this case you will write the mass of the object is 10 plus minus 5 gram, that is 0.005 kilogram. And here you are right, the mass of the object is 10 plus minus 5 gram. So in that case, mass of the object can be from 10 minus 0.005, that is 9.995 to 10.005, and the range I get here, it is very much accurate because the range is very less. 9.995 and 10.005 are very much similar to each other, but from here the mass of the object can be 5 gram to 15 gram. It is a very bad measurement because you are saying that I have taken a mass, that mass can be from 5 gram to 15 gram. So you see that absolute error is not give you the actual information that how the error is, how much the error is. So we calculate the relative error. What is relative error? So let the measured value is A and the error is delta A. Therefore we call that relative error. Is what is relative error? Relative error is the error per unit. That is, if mass of an object is 10 gram and you have got the error 1 gram, then the relative error is the how much is the error per 1 gram. In 10 gram you have got error 1 gram, that means in 1 gram the error is 0.1 gram. So the relative error is given as delta A by A. This is the relative error. And the percentage error is error per 100. So percentage error is given as delta A by A multiplied by 100%. So this is percentage error. Now I will take an example. Let the time period of a simple pendulum has to be measured, and we get the values are 2.63 second, 2.56 second, 2.42 second, 2.71 second. These are the time period of a simple pendulum. So we have to now calculate the average value of the time period and the percentage error, relative error and absolute error. So the time period of the pendulum T is equal to 2.63 plus 2.56 plus 2.42 plus 2.71 by 4. It is equal to 13.12 by 4. It is equal to we have another value 2.80 plus 2.80 equal to 13.12 by 5 second. It is equal to 2.624 second, equal to 2.62 second. So we get the time period of the pendulum as 2.62 second. So this is the time period. Now we have to find out the respective error. So the first measurement was 2.63. So delta T1 here 2.63 minus 2.62 mod equal to 0.01 second. Delta T2 it is equal to 2.56 minus 2.62 equal to 0.06 second. Our third measurement was delta T3 equal to 2.42 minus 2.62 equal to 0.20 second. Fourth measurement was 2.71 minus 2.62 equal to 0.09 second. And the fifth measurement was 2.80 minus 2.62 equal to 0.18 second. So these are the error in the respective measurement. Now I will find the average value of the error. So mean value of error is equal to 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 divided by 5. It is equal to 0.11 second. So we can write that measured value of time period is equal to 2.62 plus minus 0.11 second. Now we have to calculate the relative error. The relative error here is equal to delta T by T is equal to 0.11 by 2.62. Equal to 0.041 or 0.42. This is relative error. No unitless relative error. and percentage error is equal to delta t by t into 100%, that is 0.042 into 100% equal to 4.2%. So 4.2% is the percentage error. So this is the first class of error analysis. In the second class I will discuss tomorrow about the combination of error. This is addition of error, multiplication of error, subtraction of error, division of error. And then I will discuss few tricky questions with example. Thank you.